Hello, can you hear me? Hello? Yes, hello. So if you can hear, we start our new chapter today, our lecture today. We start our lecture. Now, yesterday we finished one chapter like momentum inertia, last class, last Thursday. You can remember. And today we'll start chapter 8. So we have finished actually all the chapter, and I told you that the chapter 7, 9, and 10 is a continuation. That's why we skip chapter 8. Now we will start chapter 8. Chapter 8 is a friction. Is a chapter friction. So are you ready? Are you ready there? The chapter friction is a very important one. Tell me anyone, can you give me anyone example of the friction in daily life? You know the friction, what is friction? Tell me please. You have any idea what is friction? Hello? when we push something, it will stop because of friction. Yes. Force between surfaces. Yes. Force between surfaces, or you can tell that the resistance due to the surface. Like an example, if you want to walk, if you want to now tell me before that, the friction is good or bad for us? Tell me. There is a friction. You already said you know the friction. Now it is good or bad for us? We want friction or don't want friction? Tell me. Good. Why? Why it is good? To stop of what? I see it is bad. Like example, you drive a car. You're driving a car. Okay, you have a car and you're driving a car, and the tire, your tire always the friction is with the road surface. Your tire always a friction and your tire is damaging, tearing and wearing. It's called tear and wear. So your tire has less life, and what happened? It increase your cost, right? You need to change the tire. So I see it as a friction is a bad thing for you or us. But how do you say it is good for us? Tell me. Give me one example or one reason why. The answer is correct, maybe correct, but you need to tell me why. Any idea? Any answer? Or no answer? Good test of car, yes. If there is no friction, you cannot disturb the car. Yes, you cannot disturb the car. Another example. Friction is actually a blessing for us. Is a very good and blessings for us. Blessings for us. Why? Like example, you are walking on the road. You are walking in the road. You have the shoes, right? You have the shoes. If there is no, it's responsible for many types of motion. If there is no friction, right, you cannot walk. You cannot walk, right? You always you cannot walk. You always sleep. You will always sleep. If there is no friction, you cannot walk. You will sleep and fall down. Okay, so friction is important for us. Friction is good for us. Friction is good for us. Without friction, our life will be stopped. And if it's too much friction, then it will be bad for us. So it is good and bad both for us. So we want a balance. We want balance. And what is the balance? What is the balance we learn in this chapter? Okay, friction. Introduce the concept of the dry friction. So dry friction. To present, we will present the specific application, investigate the concept of rolling resistance. Maybe we will not do that. Maybe let's go there, right? So we learn the dry friction problem after here it's finished. Maybe we'll not going that much, not there. Okay, we'll finish 1 and 2. So friction force that resists the movement of two contacting surface. What is friction? Friction, I told you, resistance. Friction is a resistance. Friction that resists force. Friction is a force. What is this? First, friction is a force that resists the movement of the two contacting surface that slide relative to one another. Like there is one surface and there is another surface, right? So this surface is your shoes. Maybe your shoes here, and this is the floor. So the friction is developed between the two surfaces, and this is contacting surface which slide to each other, right? acts tangent of the surface point. Tangent of the surface point, contact with the other body. Tangents means if it is the surface, so it is acts through the tangent body. Tangent. And then opposing the possible existing motion of the relative points. Two type friction. There is fluid friction and there is the Coulomb friction. Now, fluid friction. What is the fluid friction? Fluid friction is exist with the fluid friction is exist with when the contacting surface are separated by the film of fluid. So, and depending on the velocity of fluid, its ability to resist the force. Coulombs to occur between the contacting surface bodies in absence of the lubricating fluid. Now here we are not doing this, right? If there there is surface, there is a surface. If there is a fluid on the surface and there is another thing, so in between is some fluid, then it is called fluid friction, right? This is called fluid friction. Are you there any mechanical student from mechanical engineering here? You have any student? We have any student in this course? Do we have any mechanical engineering student from mechanical engineering? For them maybe not in this course. Not in this course. In future, you will be learning the fluid mechanics or fluid friction. Fluid mechanics also civil engineering student has to learn. They will also learn, but especially the fluid friction, those things you will learn in mechanical engineering. It is more important for mechanical students, right? The fluid friction, and that specifically you will learn another courses, something in your departmental courses. But in our course, actually, we will do the Coulomb forces or Coulomb friction, or simply friction between two surfaces without any lubricating. Now let's go to the characteristics of the friction, and let's try to learn something about the friction, right? Some idea about the friction. So what is the friction, and the theory of the friction? What is friction? So simply, as example, as you told that the surface friction is the friction is the resistance between the two surfaces. Suppose, imagine that we have some block or weight or some box there, okay, on some surface, on the surface. When there is friction, we say rough surface. When there is no friction, then we say smooth surface, smooth surface, right? So consider the effect of the cause by the pulling horizontally. That means this is pulling horizontally on a block uniform weight W, which is resting on the rough horizontal surface. So then consider the surface of the contact to be non-rigid or deformable. Other part of the block are rigid. So the surface is the rigid. Suppose the rigid or something, whatever, doesn't matter. If so happen, and now what happened? You have a some block or the something there, some weight, and you try to pull down. So it will start to move that side. It will try to move, not start. It will try to move, or you want to move it. You want to move, right? In which direction? By pulling it. So it will try to go there, but the friction, the surface will prevent you. Will try to prevent. You try to move. You want to move, or you try to move. The surface will try to prevent you in that direction, opposite direction. Okay, it will try to move you. And what happened with the between two surfaces? What happened between here and here? That is in this picture. You see what happened. What happened there is we not with very infinitesimal, very small, showing that very small. Imagine that very small forces appeared. Very small force work. This friction force work between the surface, between there and there. There between the surface, very small force start to work. As example, right? Actually, the forces start to work on that side. If you pull that side, it will. If you pull that side, the friction force will start to work. Plus the force against the W, there's a weight. Their force will be working upward. that is called normal force. That is called normal force. There is called normal force. Suppose delta n. So normal force and frictional force along the surface structure. For equilibrium, normal force act upward. So normal force act upward. The normal force will act upward. Okay, to balance the block weight W, and frictional force act to the left of the to prevent the P from moving the block to the right. So clearly, if you have W working there and P is there pulling out, so some force will be developed. It is called frictional force will be developed to prevent to move, and another force will work. Is Wn, delta n or n is the normal force against the gravity force. So many microscopic irregularities exist between the two surfaces. If you try to see the why the friction, because even we say surface is smooth, actually in our naked eye, our bare eye, only with eyes, you will see the surface is the smooth. But actually, if you see the microscopic view with the microscope, you will feel the surface is not smooth as we think. It is somewhat rough. Like example here, surface is the rough. So microscopic irregularities exist between the two surfaces, and this irregularity creates the friction. So reactive forces delta n develop at each of the protuberances. This is called protuberances, and each reactive force. So delta n will start work. What will work? Why delta n? The delta n or a small force is normal force, and you have delta F, the frictional force. But we already know if there is two force from the mechanics from the chapter 2, 3, 4 something, that if two forces work like this, there will be the resultant force. If two forces work like this, there will be the resultant force, right? So here resultant force will be work like this, delta R and the delta R, and this is here. So delta R, some kind of the resistance force or the resultant force will be working. So each reactive force consists of the both frictional component and this blah blah blah. Okay. Then what is happening there? What is happening? And for equilibrium, now there is three situations can happen. If some block we are explaining now, what happen if you want to push or pull some with P, some forces, some block, then what will happen? Three things can happen. One, it could be in equilibrium. Two, right? Two situation, it just start to move. Three, or it is already moving. These three things can happen. So now for equilibrium, we'll discuss for equilibrium. So effect of normal force and frictional loading or frictional force are indicated by the resultant N and F. So we have frictional force. So we first said there is a many force, delta F. What is delta F? Delta F, we say there is small force will work. It is delta F, and all together we say it is F. There is a small amount of delta N will work, and all together we say N, delta N and F. Okay. And then delta. So distribute the delta N, indicate the F is tangent of the contact surface, and the F will work as a tangent in the surface, just contact surface. If it is the surface, if it is a surface like this, so F will be working. F will go just with the contacting with this surface will be working. So normal force is determined from the here. We already know this. Now what is happening? So what we have? So we have N work upward to balance the W. We already know. So now for in equilibrium, so N acts at a distance x with right to the line of the action of W. You see N work at x distance. The N force, the resistance force can work. Now I tell you to understand, this is the W, right? It will work with the middle. Now when you push, when you at the rest position, at the rest position. So N will be directly at the same line of W. I draw it again. I draw it again to make you clear. So if it is W, W will be working just with the middle, just with the middle, just with the middle. And N also will be same line, will be working with W, same line. But when you start to move P there, so the force is trying to pull the block, the N also try to shift. Suppose N will be shift from here to here. N shift to here, from here to here. And this distance is X. If you push the more, if you apply more forces to the P, then N will come to here, just corner. This corner, and little bit, if you increase little bit more P, then N will come outside of this this corner, and then finally the block will start tipping. It's tipping. That block will be like fall down like this. Block start to tip. Block start to fall down like this. Okay, at the point, the corner point. That will happen. So that means if we start to increase the P, so N will be shifting toward this side. So that is their saying there. Okay, that is their saying here. So the location coincide with the centroid of the geometric center loading diagram in order to balance the tipping effect. So what is tipping effect? Tipping effect is this, is tipping. If you have something there and it is due to the action of the force, it is called tipping. It is going to fall. It is going to fall. It is called tipping. Okay. Now, if P is slowly increased, as I told you, P is slowly increased, F correspondingly increase. If you want increase P, the F means friction also increase. You increase P, friction will increase. That means friction is trying to resist the movement towards the right side. But again, your P increase, as I told you once, friction will fail. Friction cannot prevent anymore. Friction cannot be. Friction will increase. Friction will increase. P increase. Friction also increase. P increase. Friction also increase. P increase. Friction will increase. But at the same time, P increase, friction is not increasing. If friction failed to resist, and the body will start to move. Body will start to move, and P are not increasing. So P increase until it attain a certain maximum value of F. After that, F max. After that, it does not increase. Does not or cannot increase. Cannot or does not increase. And the maximum force is called the limiting starting force. Limiting, that's the limit. After that, it cannot be increased. Static frictional force. So this is called static frictional force. Now, limiting static frictional force, Fs is directly proportional to the resultant normal force N. So this is called limiting force. What is limiting force? If you keep increase the force F, P, then F also increase, but with the maximum value. So this maximum value is called limiting starting force. And limiting starting force is directly proportional to the N, this N. So this force F equal to proportional to N. But to remove the proportional, we need a constant, and this constant is mu s. This constant is mu s, and this constant is called coefficient of dry friction. Next chapter we will learn this. Next slide. Okay. Next slide we'll start. So this fits the so this is the equation. This is situation where this is the situation. So up to the equilibrium. Up to here is the equilibrium, but when the P increase and F cannot, at that time we say impending motion. That means just start to move. just motion is impending. It's called impending motion. In case of the impending motion, so constant of the proportionality, it is known as I told you, coefficient of dry friction or coefficient of static friction. It's called coefficient of dry friction or coefficient of static friction. Now there is this is phi or psi is it is called angle of friction. It is called angle of friction. And angle of friction equal to F by how this is Fs by Fn. How this is angle of friction. You see from the picture here. You see here, see if F is working there, if F is working in this direction and N work in these directions, we assume the delta Fs. This is called angle of friction. Which is angle of friction? If our frictional force working is there and normal force is working there, we know there will be the kind of resultant force, and this resultant force create an angle with the normal force, and this is called psi or phi, and this is called angle of friction. An angle of friction equal to, from the formula what we know, F by N, and there is formula F by N, tan inverse F by N. Now F equal to, we already learned F equal to Fs equal to mu s N. So we write down mu s N. So N is cancel out. So tan inverse mu s. So angle of friction equal to tan inverse coefficient of friction. This is the mu s is coefficient of friction. So this is relationship between the angle of friction. This relationship between the angle of friction and the coefficient of friction. Now, coefficient of friction is depend on different material. The value of coefficient of friction, like mu s, the value is depend on the materials. The metal or ice is 0.5, and the wood is 0.3 to 0.7, and so on and so on. Then, as I told you, three situations. Then motion, already as I told you, first will be the equilibrium. First is equilibrium. Two is just start to move. It's called impending motion. And third, 2 and 3 is called motion. So when P greater than the Fs, when P is when P is F equal to F, it is the equilibrium. Equilibrium, right? When P is slightly greater than the Fs, then it is start to move. Just start to move. When P is very greater, then it is already in moving or motion. That is telling here, if P is greater than Fs, the friction force is slightly smaller than the Fs, right? It is called kinematic friction. The friction force slightly smaller than the friction is called kinetic friction. The block will not help in equilibrium. As I told, if P is greater than F, block will not equilibrium but slide with increasing speed. This is the example, how the if friction is increased, frictional force and the normal force work, and resultant force work there. Okay. So frictional force, similarly kinematic friction. So kinematic, it is not in our. I'm skipping it. It is not. We will not focus too much here. So kinematic friction is similarly, it is called static friction of coefficient equal to static friction into normal force. Here kinetic friction equal to kinetic friction or normal force. That's it. It multiplied, like QR is the 25%. So kinematic force is the 25% smaller than the mu s static force, and the resulting force is similarly kinetic friction of the angle of the kinetic force equal to tan inverse angle of the kinetic friction coefficient. Now this is the example. What happened if P increases, like P increase? So P, we going to P like this. This is the block, and P, the force, and the P is increasing slowly. The friction is increasing. At some point, it is called the coefficient of the kinetic friction, and after that is going up. It's finally, it is called the coefficient of static friction. Still, if you are pushing the load, then the frictional force is going to down very quickly. The sub characteristic some characteristics of the frictional force. The characteristics of drive force is the force act on the tangent and the contacting surface. As I told you, friction will always work on the surface. If it is the block, so force will be always working in the surface, right? In the tangent surface. Then the maximum static frictional force is independent of the area of the contact. So it doesn't matter if area is that much, or area is the very much, or area is very big, the frictional force, it doesn't matter, it is independent. The maximal static frictional force is greater than the kinetic frictional force. That means Fs is greater than Fk. You can see from the graph also, you see Fs is higher, Fs is the greater than the Fk. Then when the slipping, the maximum statical force is the proportional to the normal force, and kinetic frictional force is proportional to the normal force. When the slipping, so whatever number F is equal to frictional connection, F is equal to mu s into normal force. Okay. As I told you, there is three types of things can happen in all the cases. Geometry, dimensional assembly to be known. Three type of mechanics problem involve the dry friction. One is at the equilibrium, another is the impending motion on the all point, another point is impending motion at the some point. Now in equilibrium, maybe this is the equilibrium, we skip it, and we already discussed something like this. We will do the one example straight away now. So before I go to style, right? Now we will do one example. Now we will start a example. We already learned the theory of most of the thing. So just repeat. There is all the simple. Just new thing. What do you think? New thing. New thing is nothing here. Only one new thing you learn here. Coefficient frictional force equal to mu a s. This is the only thing you learn there. New thing. Not all thing is same as like before. Whatever we learn, new thing is frictional force is equal to coefficient of friction into n. Okay, Fs equal to mu s into n. N is the normal force. That's the only thing new we have to learn. Another things I told you that if some block is there, if Islam block is there and normal force will be working. If it is some block is straight away like this, so with the middle point, the W always will be working at the middle of the weight, and the normal force will be working just at the perpendicular to the same line, but if you start to push the force, if you start to push, the X will be moving this direction. So P increase, S will move also that direction. As long as X is reached to that corner, it just start to fall down or tipping. It's called tipping effect. Tipping effect. So P increase more than already finally already will be tipped down. Now if you push, what will happen? If you push, the same thing will happen. It is W will be working downward, and a normal force will try to move that side, X in the left side. And similarly, if it is at this point, if we still increase the P value, so it will try to fall down. Again, tipping effect, right? In both cases, tipping effect. So if it is slight fall down, it is tipping effect. If our frictional force, there is greater than the normal frictional force, if F is greater than F, then what is happening? If F is greater than Fs, then what happened? The friction, the block can slide. Block can slide. So two things can happen. One is the tipping. One is the tipping. That means tipping means like this. The block it will tip down like this. And two number thing is can happen is sliding. Sliding means the block will start to slide, and it will go like this, sliding. It will start to move by sliding. Okay, it will start to move that side. It is called the sliding. So now we will do the example, and we want to examine actually what is going to happen. What is going to happen if some forces apply. So what is that? The uniform crate. The uniform crate. This is called the crate. This box is called in English. This box is called the crate. So uniform crate has a mass of 20 kilo. So 20 kilo is already working. 20 kilo in a force 80 newton. In a force is 80 newton. Is applied 80 newton for the crate. They determine the if it remains in the equilibrium. Therefore, the coefficient of static friction is 0.3. That means US is given 0.3. Now solve the problem. Now our question is, now they are asking us to solve the problem. What do they solve? What they are asking to solve? They are telling that uniform crate is there. So determine if it is retained. The question is like this. The question is, you have to answer. We have to answer. It is if determine if remain in equilibrium or not. It will be equilibrium. It will be in equilibrium or not, right? It did not ask me it will tip down, tipping down, or it will slide, or it will slide. But in exam maybe we will ask you, okay, number one, whether it is in equilibrium, it will be in equilibrium, yes or no. If your answer is no, then next question will say how it will happen. It will tip down, or it will slide. How it will be unequilibrium, non-equilibrium, it tip down or slide down. That we have to answer. Now let's just start doing the problem. Let's just start the problem now. Are you clear about the question? Tell me first that. Do you understand what I'm telling? What I told you so far? Are you clear? Yes, Kamal Jamal, you are saying that yes, you understood that what I'm going to tell you. 6193. You are the student of all the students of 43. So I'm going to ask your name, and you please tell me you. Now, if some of you student has any problem with the attendance that you cannot attend the exam, it's a serious situation if you happen, but please let me know in advance. Otherwise, if you absent more than 25%, you will not be allowed to sit for exam. Then will mark not will be appeared in the banner. Your name will be not in the banner, and you will be shown an F. Tell me, Muhammad Hafiz is there? Muhammad Hafiz. Muhammad Hafiz is there, right? Yes. Then Muhammad Abdul Mazen. Muhammad Abdul Mazen. Muhammad Abdul Mazen is not there, right? I will put absent. Okay. Kumal Hussain. Kumal Hussain. Kumal Hussain, absent. Muhammad Abdul Aziz Hussain, Muhammad Abdul Aziz is absent. Muhammad Abdul Aziz absent. Muhammad Ahmad bin Abdul Rahman, who is that? Muhammad Abdul Aziz, okay, there. Muhammad Yusuf bin Muhammad Yusuf, Muhammad Yusuf is not absent, right? All right. Then Muhammad Sami, another Muhammad Sami, Muhammad Sami Sulaiman is there. Ahmad Tahir, Ahmad Tahir, Ahmad Tahir absent. Abdullah Muhammad bin Abdullah, Abdullah Muhammad bin Abdullah, absent. Abdul Malik, Abdul Malik Khalid, Abdul Malik is there. Okay. Umar Abdullah, Saleh bin Munir is there or not? Tell me please. Saleh bin Munir is there. Doctor, I have internet problem. Ahmed Tahir. Okay, it's given. Okay. Abdul Aziz, Abdul Malik is there. Umar Abdul Aziz is there, right? Yes, you are there. You are there. Ali Abdul Munaim. Isa Abdullah Isa. Isa Abdullah. Isa is not there, right? Isa is not there. Yahya is there. Yahya is there. Muhanna Walid. Okay, I tell you some name. Muhammad Sami bin Ahmad is there. Muhammad Sami bin Ahmad. It's not there. Muhanna is there. Talal Jamal. Yes, here. Saud Usama. Hussain Ali. Hussain Fares Fahad. Then Abdulillah. Ali Jawad, Hassan Abdullah Saadun, Ahmad, Hassan Abdullah, Ahmad Imad is there, right? Then Abdullah Saadun is there. Abdullah Saadun is absent. Okay. Ahmad Dia, Muhammad Salah, Hassan Jawad, Firas or Fares, tell me name. Firas Fadel is there. Abdullah Saleh, tell me, Ahmad Abdul Rahman bin Abdullah. Is there anyone? Ahmad Abdul Rahman Abdullah is there? Anyone? Firas Fadel is there. Firas is there. Where is Firas? Abdullah. Just wait. Saad Muhammad. Where is Saad Muhammad? Abdullah Saleh is there. Abdullah Saleh, you said yes. And then Saad Muhammad, yes. Just wait. Abdul Munaim, right? Abdullah Saad. Abdullah Saadun 25. Yes, Abdullah Saadun is there. Okay. Abdullah Saad. Abdullah Saad is there. Abdul Munab. Just a little bit. Wait, please wait. Abdul Munab. Is there anyone? Tell me name. Abdullah Umar bin Muhammad. Abdullah Umar bin Muhammad. Tell me, is there? Not there, right? Abdul Munam is there. Yes, there. Abdullah Saad is there. Abdullah Saad is there. Kamal Ashraf, where is Kamal Ashraf? What is your serial number? Kumail, Kumail Hussain. Kumail Hussain is there. Kumail Hussain is given. Abdullah Saad is given. Umar Wahid. Umar Wahid. Umar Wahid is there. Umar Wahid absent. Umar Wahid absent. Muhammad Shabir. Shabir is there. Shamsun Saleh. Shamsun Saleh is there. Umar Ahmad, right? Umar Ahmad. So Jamal Raed. Jamal Raed. Jamal Raed is absent. Oh, he is there. Kamal Ashraf. Kamal Ashraf absent. Umar Usama. Umar Usama there. Abdullah is there. Musa Ahmad Isa. Abdullah Saad. Abdullah Saad there. Is there anyone? Abdul Rahman Sabhi. Tell me please, Abdul Rahman Sabhi. Is there? Not there. Umar Wahid is there. Okay. Now I double check. Right? Abdul Aziz Mazen is there. Abdul Aziz Mazen. Abdul Aziz is there now there. So absent. Muhammad Abdul Aziz bin Hassan absent. Isa Abdullah. Isa Abdullah absent. So I keep you absent and double check. So I give you a confirm now. Fine. Now actually we don't have time more. I'm sorry. So we will start the. So today we learn the theory part of it. Next day maybe we will start. Next day we will start the numerical problem. Okay. Now my question is, do you have any question? Tell me please. You have any question? Please. Okay, if you don't have questions, so you can leave it. You can leave now. So our class for today is finished here. Now, okay, fine. All right. Doctor, how can I know if it is equilibrium or not? I will teach you next class. Yes, this class I also can tell you. As I told you, if the P force P, the force, pushing force or pulling force, is equal to Fs, it is in equilibrium. Okay. And another force, I will show you the example. Okay. If P is slightly increased, then it will be in motion. Or it will just start. It called impending motion. It will impending, just start. And if P is slide, yes, motion or slide or tipping. As I told you, there is two things can happen. Slide, one is sliding, another is tipping. Two things can happen, and there is two conditions. When it will slide, there is a condition. When it will tip, when it will tip, there is a condition. So these two conditions we will learn in next class. Okay, if you have no more questions.